Hello everyone, this is Kaz from Yahoo Japan. This time we would like to talk about the efforts and overview of OCP at Yahoo Japan infrastructure. Because of the health issues, we couldn't share the session in OCP Global Summit last March. Instead, we will share the session at OCP Virtual Summit that we were supposed to talk about last March. For convenient and smooth sharing, we decided to pre-recording for this session. Let's get started. This is the title of this presentation, and we will talk about the situation of OCP and details about Sever, Racks, and PowerShells, which we adopted. We will explain about this with the three people who are part of Yahoo Japan infrastructure divisions, including Keita Uchida, he is in server engineering team, Chin Zhou, he is in Datacenter operating teams, and me, I am part of server engineering team, same as Keita Uchida. Additionally, since this year, Yahoo Japan will be working as a Platinum membership member of OCP community. There are three topics we would like to cover for this presentation. Each topics we will explain with each people. Let's begin with the first topic. This topic including the overview of our company, our infrastructure, and our OCP outline at this time. Once again, let me explain about the speakers. They all belong to the infrastructure division at Yahoo Japan and also have responsibility for OCP activities such as driving, evaluation, management for OCP products. Let me explain Yahoo Japan in short. Yahoo Japan is a Japanese internet company. It's one of the CSPs, and we are located in Japan and the head office is in Tokyo. We have more than 6,000 employees, with over half of them being engineers. We are founded in January 1996, have more than 20 years company history, and also provide over 100 services on the desktop and smartphone environment. We are also top-class application publisher for smartphone market in Japan. We are one of the most famous portal sites in Japan. As you can see from the left on slide, is our portal site designed for desktop and smartphone. On right side, this is the user volumes on desktop and smartphone platforms. According to this survey, for PC platform it is the largest user volumes, and for smartphone it is the second largest user volumes in Japan. For these explanations, we have large employees, various services, and users. So this means we also have large-scale infrastructure. Next is overview of Yahoo Japan infrastructure in short. Regarding the number of servers, it is almost 80,000 physical servers. Over 90% of them are standard servers, under 10% is OCP servers. As for racks, we have over 5,000 racks in our data centers. Over 95% of them are standard racks, other is OCP racks. We also have the data centers in Japan by ourselves. As typical examples, there are two main data centers in the west of Japan and east of Japan. This slide describes OCP overview at Yahoo Japan. Since 2016, that was the first adoption of OCP in Japan. Since then, we have been adopted OCP in our infrastructure year by year, including Leopard and TugoPath. In order to explain the scale of OCP at this time, we have over 4,000 OCP server nodes in our data center. Those OCP servers have been installed in 3 data centers in Japan. This slide shows the organization of infrastructure at Yahoo Japan. We have one division which manages and operates our production infrastructure, what is called Site Operation Division. Site Operation Division has over 100 plus infrastructure engineers and covers the responsibilities such as operating system layer, hardware, networks, and platforms. Mainly, the Infrastructure Tech Second Department has the responsibility for OCP activities. These presentation speakers belong to this department. Other than Site Operation Division, we have the division related to OCP activities. That is an accounting division. They have responsibility for the negotiation, communication, and making a contract with OCP vendors such as Win-Win and MyTac, and also key component suppliers, and also management for server assets internally. For adopting OCP, we collaborate with 2 divisions who are Site Operation Division and Accounting Division, because it is needed a wide variety of works for OCP. From the perspective of cost about OCP, this is the main reason we are using OCP product as our infrastructure investment. Because, of course, as infrastructure investment, the cost performance is the important thing. There are 2 points. First point is initial cost, that is CapEx cost, which is server unit cost comparing between standard server and OCP server. We can measure and to be confident there is a much cost performance of server unit cost by using OCP. In contrast, other point is OPEX, including electricity cost, power consumption, air conditioning cost, and on-site operating cost, such as server racking, unracking, and replacement for FRU and CRU of server. However, currently it is hard situation and environment to measure those OPEX things because our systems and facilities are not enough to design and measure those metrics. This is one challenge, to recognize the benefit and advantages of operation cost of OCP. We are still continuing to address these challenges for optimizing metrics for OCP. As another challenge, we are working on to expand possibility to adopt OCP product in our data center. That is combination with ESA and Open Racks in our facility. Our typical data center is designed for standard racks. This means if we want to adopt OCP product, we have to replace rack with additional cost. But now we can adopt OCP using ESA with minimum additional cost compared to replacement of rack from standard rack to OCP1.
I am in charge of server engineer at Yahoo Japan. In my section, I introduce about YJ's server configuration and server operation. First, I talk about Yahoo Japan's typical server configuration. In Yahoo Japan, OCP servers are used to hypervisor of our private cloud infra. Server models is Tioga Path. We use basic SKU because we would like to keep simple and remove difference between server vendors. Details of server configuration are as shown. About this, we use 2.5 SATA SSD for boot and add in-card NVMe SSD for data. We consider that use M.2 NVMe for boot because make physical configuration simple. Let me move on to the what changed after using OCP servers. Of course, big benefit of using OCP servers is front accessible server shape. It improves our operation in data center. This time, I talk about other benefits of using OCP servers. First, we can use same model from multi-vendors. Second, we can communicate directly server vendors. Next, I'm going to explain details of those benefits. YJ's server procurement policy are multi-source and compare each PO on regular servers. As server vendors increase, server models increase. So our data center has many server models. On OCP servers, specification is open. Some server vendors provide same server model. So we can use same server model under our policy. It means multi-source. Before using OCP servers, we have a problem caused by multi-server models. As a result of balancing multi-source procurement and price control, some models have a few nodes. We have to dispose team resource for troubleshooting and operation tool development. So we cannot focus mainstream server model. After using OCP servers, we can use same model from multi-vendors. We can use same tools and use experience of another vendor server's node. I talk about details of benefits by using same server model. As I said, our data center has multi-server models. Sometimes, some server models are working on same rack. On regular servers, server length and server racking rails are different between server models. So, sometimes we are not able to racking or unracking server nodes caused by racking rail compatibility, and heat pool is occurred by server length difference. After using OCP server, we can use same size and same shape server nodes. Tioga Pass does not have racking rails. There is no racking issue and no compatibility issue. OCP server free us from physical compatibility issues. Next, I talk about troubleshooting operation. Each server models have vendor-specific operation tools and system event log formats. Using many server models, we have to develop complex cell message parser and operation tools. Using OCP server, we can use same cell format in many cases. It is defined by open documents. We can develop parser and operation tools easy. So, OCP servers free us from implementation of complex operation tools. Finally, I'd like to explain issue management. In Japan, between end user and server vendor is so far. Sales company and server vendor Japan branch are in between end user and vendor. It has benefits for saving operation costs, but it becomes black box, so we cannot manage issue status easily. After using OCP servers, we can communicate server vendor directly. Of course, it is need more effort than before, but we can manage issue quickly and get detailed issue status. I'm going to give summary of this section. Yahoo Japan uses Tioga Pass for our cloud infra. Tioga Pass is provided by multi-vendors. It enables us that we can use same size and same shape servers from multi-vendors. We can use same operation tools and use experiments of another vendor nodes. Yahoo Japan became able to communicate server vendor directly by using OCP servers.
Hello everyone, my name is Chen, a data center engineer of Yahoo Japan. I'm very glad to share my topic with you. Then I'd like to talk something about deploy the OCP rack into our exact data center. Okay, this is the agenda. Firstly, let me introduce one data center of our Fukushima data center. Fukushima data center now have 5 buildings in using and have about 3 buildings space for expansion. 5 using building with a different cooling system. Number 1 to 5 building use the direct outside air cooling and water cooling as cooling system. Number 1 and 2 building has 3 floors, reception, operation room, and common room on the first floor. Data hall is on the second and third floor. As the figure shows, the warm air from hot SO of the second and third floor will go through the hot chamber and the chimney go to outside. We use the directly outside air for cooling down the IT gear. Let me talk about adopt OCP Racks to DC. Unlike standard 19-inch rack, OCP IT gear is pre-installed into the rack. It can help us to cut down the cost and the time of installation. This is no power supply on an OCP server. Every single rack only have 1 or 2 power shelves, convert AC to DC. As a result, it have higher AC to DC conversion rate than traditional rack. No tool required for regular maintenance, also can save the precious engineer resource. Our OCP journey began from the 2016 with the adoption of version 1 OCP server for module data center as level 11. Then we expand to another data center in 2017. This time we adopt the version 2 OCP rack to our existing data center, but not as level 11. Why we don't adopt that as level 11? This is our delivery route of data center which want to adopt version 2 OCP rack first. The data center was designed for EA rack that which need to assemble the rack inside of IT space. But OCP racks arrive full load, so access route from the goods in area to IT space was just to consider the IT gear size, not include rack. Let me show the size of OCP rack and the EIA rack. Although the EIA rack is higher than OCP rack, but it did not need carrying as it is. Let's look at the delivery route again. Yes, when before carrying, we do the investigation to make sure if we can do the level 11 adoption. The answer was no. Which part do you think we start? Absolutely, it's the door. We want to use the caster to carry the rack, but there are not enough height. So we can't adopt OCP server to existing data center? No, there are another way. ESA can slow it. ESA is an enclosure sub-assembly designed to enable EIA rack user to adopt OCP products. By use ESA, we can installation the OCP gear into our existing EIA rack. In 2018, we had adopted the OCP version 2 racks to our existing data center at level 11. Okay, next I'd like to talk about our rack configuration. In 2016, every rack has 36 nodes, 1 power zone, and 1 switch for service line, and another one for management line. In 2017, every rack has 30 nodes, 1 power zone, 4 switches for service line, and 1 switch for management line. In 2018, every rack has 31 nodes, 2 power zone, 2 switch for service line, and 1 switch for management line. In 2019, every rack has 24 nodes, 2 power zone, 2 switch for service line, and 1 switch for management line. Okay, the next topic is about seismic construction. What we need to consider about seismic construction. You may not know that there are approximately 2,000 earthquakes every year in Japan. This figure shows that the probability of the earthquake of lower 6 intensity or above occurring within the next 30 years. Not only standard 19-inch rack needed to clear the seismic test, but also OCP rack. We also need to fix the rack to floor with bolts, like this, and connect to each other become stable. Okay, the last topic is about the power shelf. Mostly power shelf not have the single phase 3-wire model. Due to the data center facility, we can only use the single phase 3-wire power shelf. Let me give a brief introduction of the power shelf that we are using. MWOCE's 211 is a 15 kilowatts 21-inch 1OU OCP complete power shelf with a remote management unit. And this power shelf is from Fuji Electric. FH07500JPB is a 7.5 kilowatt 19-inch 2-unit OCP compliant power shelf. And this one is from Fuji Electric 2, a 7.5 kilowatt 21-inch 3OU OCP compliant power shelf with 6 AC output. This is all for my presentation. Thank you.
In order to summarize for today's presentation, we have own data centers and the share of OCP servers has been expanding at Yahoo Japan infrastructure. And in terms of on-site operation, is enough serviceability for our server infrastructure. Regarding facility layer, racks, and power shelf, we also have been continuing to approach to implement OCP in our infrastructure with several efforts, as you can see from this slide. That's all for our presentation. Thank you for watching and listening.